Okay, grade. Sorry, excuse me. Okay, grade 8. We are starting lesson 6 on scientific notation. Okay? Lesson 6, chapter 1, scientific notation. It starts on page 51 of your book. Okay? All right. Now, lesson 6, page 51 to 58, that's the whole lesson. The whole lesson is in these pages, okay? And I wrote our date. Today's date is September 20th, 2020. So what is scientific notation? It is a number. It is a way of writing numbers, yes? Just the same way you write fractions, decimals. So this method is called a scientific notation. And just like the way the name says, it is mainly used by scientists, yes? People like mathematicians, chemists, astronauts, finance people, all these people. Anybody who deals with numbers, okay? And why do we need to write numbers using scientific notation? Because some numbers are very long. If I want to measure the distance from Earth to Mars, I can't finish writing all those digits on my paper because that distance is too long, okay? Or if I want to measure how much a grain of salt or how much a grain of sand, that is too small. I need to use a microscope to measure, yes? To see how big it is or how wide it is, yes? So because these are very small values or very big values, we have to write them using scientific notation. So scientific notation is an abbreviation. It is a short form of you writing very long numbers, very long values and very short values, okay? So that is how, if your number has very many digits, okay? So because we can't write all these digits on a piece of paper, our paper is just this wide. And the number has so many digits up to the door over there. So because of this, and these values represent either a very small value or a very big value, okay? So that is why we have to write them in scientific notation, okay? Now, how to write a number in scientific notation correctly. Okay? First, you have to realize scientific notation is made of two parts. These two parts are what make your number called scientific notation. Okay? So, the first part is called the coefficient. And then you multiply the coefficient with a power of 10. This number here has to be a power of 10. It can't have any other base but 10. Okay? Now, let's look at the coefficient. Very important. This value that you will write here should always be positive. Always. Okay? Then, it should always be greater than 0. It should be a whole number greater than 0. There, what I should write? It is always greater than 0. And a whole number. It must be a whole number. And it must be a whole number. That means it cannot start with 0. That's what I'm trying to say. In fact, let me just write that. Instead of me writing this, say it cannot start with 0. I'll write it over here. A can never start with 0. It cannot start with 0. Okay? It cannot. It has to start with 1 or 2 or 3 or 4. Are we together? If you put 0 point something here, it will be wrong. Okay? This number that you write here should always be less than 10. If it is more than 10, it is wrong. Okay? So, you can only use 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. If you write 10, you are wrong. If you write 0, you are wrong. Okay? So inside, when we are writing in mathematics using the signs, we are saying A has to be greater than 1 or equal to 1. A has to be greater than 1 or equal to 1. Okay? That's how you read this part. And then you say A has to be less than 10. Do you see? A is 1 or greater. A is also less than 10. Okay? You will see what I mean as we do the examples. Now, here, on the power of 10, the base will always be 10. This base must be 10 all the time. And your exponent, where we've written n, is an integer. What do we mean by integers? They have to be negative or positive whole numbers. I should not see a decimal over here. Okay? So it is either -1, -2 like this, or 0, or 1, 2, 3. There you go. Forgot to put 0 here. So it has to be positive, negative, or 0. You cannot say 0.1. No. It cannot be a decimal. Don't put a half over here. Then that will not be scientific notation. It will be something else. If you put a fraction or a decimal, it stops being scientific notation. Are we together? All right. So how do you know? There are some rules you should know when you're writing scientific notation, okay? If the number they gave you is greater than 1, then the n will always be positive. This number will be positive. If your number starts with 0, then your n will always be negative. Okay? So when you're given a number and they tell you write it in scientific notation, if it starts with 0, n is negative. If it starts with a number greater than 0, which means from 1 and above, then it is positive. Are we together? So if your number is greater than or equal to 1, or equal to 1, then n, I write it over here, then n will always be positive. Okay? You will see what we mean by that as when we start doing the examples. Okay? All right. So here in this question, they have said, write each number from scientific notation to standard notation. How do I know this is scientific notation? They gave me a coefficient with a power of 10, and I am multiplying. And if you see my coefficient, it is greater than 0, and it is also less than 10. How do I know it is less than 10? 6 is less than 10. 6 is also greater than 0. Okay? All right. So now they told me to write it in standard notation. So I wrote over here, look at the exponent. The rule is look at the exponent. If you look at the exponent, if it is positive, you then go to the right. You're going to go to that side, this side. If it was negative, you will go to the left, this side. Okay? That's what I wrote here. So let's look at our question. My exponent is positive. I'm going to write it to the right. Even when you're working, you need to do this. You write positive, you're going to go to the right. So when you're checking your work, it is easier. And what do I mean you're going to go to the right? You're going to go to the decimal. So you will write just your coefficient over here. And then this is the decimal that is in your coefficient. You're going to move it to the right 4 spaces. Spaces means every number gets a U. Every number gets a U. Okay? So let's do this one. My decimal was here. I'm going to move it to the right. 1, 2, 3, 4. And I'm going to confirm that I really moved 4 spaces by writing my labels. I'm going to label each U so that I know I counted. Don't draw your U's like this. No. You see the way mine are? Draw them big. 1, 2, like that. I don't want to see things like this. No, no, no. They have to be big and they have to be spacious. Okay? All right. So what do you notice? This U is empty. If this U is empty, you put a 0. For every empty U, you must put a 0. Now let us write our answer. Our decimal is no longer here. It has moved. It has come here. Okay? So our answer is what? And you box it just like that, and you put your comma. 62,490. Okay? How do I check? I can check. So my check would be times 10 to the 4th power, which means 1 with 4 zeros. And then I write my coefficient. This is me checking. I am checking to make sure my work is correct. So how do I do when I'm multiplying a number with zeros? So 6, I just write my coefficient, 6249 with 4 zeros, 1, 2, 3, 4. And then for every digit after the decimal, I cross out the 0. So 9, 4, and 2. So this is my answer. And then I put my comma. And just like that, if I have 3 digits after the decimal, I cross out 3 zeros. You can either do it this way or you can do it this way. Whichever way you want, you choose the best way for you. Are we together? You choose what is easier for you. If you do this method, you must check with this method, okay? All right, now let us look at this one. What do you notice? Your exponent is negative. And because it is negative, you're going to go to the left. The left is this way. What are you going to move to the left? The decimal. Your decimal is here. You're going to draw a U and go to the left 4 times. 1, 2, 3, 4. Where you stop with your last U, you must put a decimal. When you put this decimal, you must put this 0. Are we together? So, when you're going to the left, your number must start with 0. I should not just see a decimal. There has to be this 0 over here. Okay? Your exponent should stop with the decimal. It should not go with this 0. It should stop here with the decimal. Okay. So now, every empty U, we will put a 0. Now let's write our answer. Our answer is 0.1236249, and I box my answer. Okay, let's do this a different way. So that becomes 6 and 249 thousandths times 10 to the negative 4 power. What does this mean? Remember, we said when our exponent is negative, it becomes a fraction, 1 over 10 to the 4th power times 6 and 249 thousandths. Okay, so now I will write this as 60249 over 1, because this is a fraction, yes? So I want to make also this a fraction. I'll write it over 1 times 1 over and 4 zeros. Okay? So I am dividing my numerator with this denominator. That is what I am doing. So 6249, and you're dividing with 10,000. Okay? If you're dividing with 10,000, if you do this long division, I don't know if we have time to do that. You do long division and check if you're going to come up with this. So you will put 6.249 and you put 10,000 out here. And then you do long division. Can 10,000 go into 6? No. Can it go into 62? No. Can it go into 624? No. Can it go into 6,249? No. You put a 0. Can it go into 62,000? Yes. 6 times. So 60,000. You subtract, you get 2,490. Can it go? Then you bring another 0, like that. It will go like this. 20,000, sorry. You subtract. Then you get 4,900. You bring down another 0. Like that. You continue. You should end up with 4,000. You should end up with 4 and 9 over here. Because you're going to minus 40,000. And then you're going to get 9,000. And then you're going to bring another 0 down. You're going to bring another 0 over here. And then you're going to subtract 90,000. Like that. Let me just add it over here. And then you should get a 0. And you see, if you do long division, this matches this. Okay? So I have shown you when the exponent is a negative, and I have shown you when the exponent is a positive. Okay? Now, let us do when we've been given a standard number and we want to write it in scientific. So a standard number, let us say 28. Okay? So they've given you 28. They told you to write it scientific notation. How do you know? Because this number is already greater than 10. So that you know this cannot be your coefficient. Okay? So, and remember we said A has to be less than 10. And then you should have 10 to the nth power. Now we need to write our A. So this is your question, 28. Where is the decimal? The decimal is here. If you don't see the decimal, it is at the end. You must put it over there. Now, after you put your decimal, you go to the beginning of your number and you box the first 2 digits. So the first 2 digits of this number is 28. I'm going to box it. And then this is what I am calling the engine. Okay? This is your engine. Box your engine. What is in your engine? Only 2 digits. The first 2 digits. Okay? In your engine, the first number cannot be 0. The second number can be 0. But the first one should not be 0. Okay? So, I'm going to move my decimal inside my engine, and it is there. So now, my new coefficient is 2 8/10. I have to multiply by 10. Now I need to worry about who is my exponent. How many times did I move? I moved 1 time. So I'm going to not write anything because it is 1. Okay, let me just write it for now. Remember we said, then you will write it correctly because we said when the exponent is 1, you don't write it. Now, how do you know this exponent is positive? Because your number did not start with 0. Because this number did not start with 0, my exponent is positive. And this is my answer in scientific notation. Okay, let's do another one. So we're going to do another one. we're going to do 285. Let's do that. Okay? So we're going to write it again. That's the question. You're writing it in scientific notation. You write 285. I am looking for the decimal. I don't see it. I will put it over here. After I put my decimal, I look for my engine. The engine is always in the front of the car. So if this is your car, the engine is in front. The first two numbers make your engine. Now, in this engine, this decimal has to come here in between the two digits. So I'm going to move it. 1, 2. Okay? Now, the numbers in your engine can only be 2 of them. And the first one should not be 0. Okay? So now we're going to write our answer. So this is step 2. Then this is step 3. So we're going to write 2 and 85 hundredths times 10. How many times did you move your decimal? 2 times. So I'm going to write 2. And then I look. Did this number start with 0? No. So my exponent is positive. And I box it. Okay? Let's try another one. Example 3. Let's try 3, 4, 5, 9, 6. Let's put the decimal. Yes, I'm going to put the decimal here. Okay, so this is your number. Or let's add some more digits. Let's add 2 and 7. Okay, so there is your number. 3,459 and 627 thousandths. Now you're supposed to write this number in scientific notation. So you write your question back down. 3459 decimal 627. You look for your engine. Your engine is 34 right here. You want this decimal to come here. So let's count. 1, 2, 3. So your new decimal is between 3 and 4. Then you write 3, 4, 3, and then the decimal 4, 5, 9, 6, 2, 7. You must write everybody. You cannot write this decimal because you already moved it. How many times did you move? 1, 2, 3. You must count how many times you made the U. Every number as you're moving should be in the U, every digit. Then you write times 10 to the third power. How do you know this 3 is positive? Because this number did not start with 0. And then you box your answer. Okay, let's do where one of these numbers is 0, where one of the digits is 0. So you have example 4. So we will do, let's do 304, 2, 7, and then put a comma and put 5. Put 5 and put 6, okay? So this is a decimal, put a decimal and put 5 and 6. So now write your question down. So this is like that. Step 1, find your engine. Your engine is your first 2 digits. Okay? After you write your first 2 digits in the box, now you want to move your decimal. 1, 2, 3, 4. Your decimal must move inside the box. It has to go there between your 2 numbers. Okay? Then you will write 3.042756 times 10. Then you count 1, 2, 3, 4. You write 4. Then you check if it is negative or positive. It is positive because this number did not start with 0. And there is your answer. Okay, so this is part 1. I will do part 2.